Hi everyone, I'm Raymond and welcome to this video. In the previous video, a step-by-step procedure has been demonstrated to complete the initial setup of IGT-22-DEV. But the built-in Modbus was not shown in that video. If you have finished the initial setup, you might see something like this, and there is not any reading of temperature and humidity. In this video, I'm going to show you how to configure your IGT-22-DEV to enable its Modbus and make the result visible on this demo dashboard. Actually, after the initial setup procedure, the Modbus has been already enabled via TTY-S2, which is an RS-485 port on IGT-22-DEV. If you got an identical sensor as mine, you only need to make the correct wiring to have it work. However, there might be hundreds of Modbus sensors, and they might have different configuration and register mapping. Therefore, it's practical to know how to configure it with your own devices or sensors. It's recommended that you watch the initial setup video, complete the procedure, and prepare a Modbus sensor and its manual before going on. Let's first take a look at how the wiring has to be done. The RS-485 port we are going to use is located at the X3 connector on the top side of IGT-22-DEV. The 7th and 8th pins counted from the front side. Connect these two pins to your Modbus device and take care of the A and B signals, or sometimes called data plus and data minus. They have to be well matched. It means A or data plus of the Modbus device has to be connected to D plus of IGT-22-DEV, and B or data minus of the Modbus device to D minus of IGT-22-DEV. If your Modbus device is not self-powered and required for an external power supply, remember also to connect it to a proper power supply unit. Whatever Modbus devices you are going to connect to, you have to get its manual of Modbus. There are some essential information there. The first sensor I'll use as an example is from Carlo Gavazzi. Here is the Modbus manual I got from the distributor. With this manual, we can find that the interface is RS-485. The pin names of the interface are D plus and D minus, which are identical to data plus and data minus, as what I mentioned earlier, and also some parameters for communication, such as slave address, baud rate, and data format. Most important thing is to find the default. Here you can see the default address is 1, and the default data format is 9600 N81, and keep them in mind. We will use them later. Now let's try to see something about reading temperature and humidity. On page 3, it tells the temperature is in a holding register at address 564, and the humidity is at 566. These two values are very important for us to get the readings. And in the last column, it shows the definition of the readings. It means once you get the temperature and the humidity, you have to divide it by 10 to get the final values. Your device might have different register addresses for the readings, and different definition of the readings. So you got to find them from the manual of your devices. I will also show you a tricky thing that sometimes confuses Modbus users. On page 7, it gives an example of Modbus data frame to read the temperature from this sensor. We can find that the starting address here is 0233 in hex. It is 563 in decimal. And it's different from the 564 we saw previously on page 3. I don't want to jump into the detail. My suggestion is to increase or decrease by 1 if you have problem reading the registers. It's only possible to connect to the devices if you have the correct communication parameters. However, these parameters are usually writable. It means the data format might not really be the default values upon you get it. Therefore, from my experience, I will usually test the Modbus devices with a third-party Modbus utility to ensure the parameters are correct. I'll use modpoll today. It's a lightweighted and precompiled freeware supporting various architectures. You can evaluate the sensor with your host computer. I'll demonstrate this on IGT-22-DEV. Let me first log on to the IGT. Open the browser and go to the address of your IGT. This is the local IP address assigned to my IGT in my studio. Use your own one or the default IP address of Undies. If your IGT is connected to your host computer with a USB cable. Now let's input the username and the password. Click on the login button. Modpoll is not pre-installed. We can download it with wget command. It will be saved as a compressed file. So we use tar command to decompress it. If the Thingsboard-Gateway has been started, it's recommended to stop it before the evaluation. This will make the job simpler, because Thingsboard-Gateway uses the same serial port and running Modbus in the background. After Thingsboard-Gateway has been stopped, we can use modpoll to get the readings from the sensor. Let's try temperature first. By definition, we have to divide the readings by 10 to get the final values. Since we get the reading 285, the actual temperature is 28.5. I'll briefly explain on the parameters. A means slave address, and A1 indicates that we are going to talk to slave 1. B is baud rate. PDS provide the data formats, and it means N81 here. T4 is for reading holding registers. R is for register address. We use -1 to force it to read once only. And the last part is DEV-TTYS2. It indicates which serial port to use. If I change the register address from 564 to 566, then I will get humidity. So the actual humidity is 62.1. So far, we have confirmed the data format is correct and the sensor works well. Let's complete our work by modifying the configuration of Thingsboard-Gateway. After the initial setup, a specific configuration file of Modbus RTU has been installed. We can edit this configuration file using this command. Since we have already confirmed the register address and data format of the sensor, it's very easy to apply them to the configuration file. Let's simply go through it. If you are going to use Modbus RTU via the built-in RS485 on IGT-22-DEV, you don't need to change the first 4 items. What you have to check are baud rate, unit ID, its previously called slave address, function code, 3 means reading holding register, and the last item is address. We know that the temperature address should be 564, but I have to use 563 instead. It's the mentioned trick of increasing or decreasing by 1. After the modification, use Ctrl X to leave the editor and go back to the command line. And remember to save the file. We need to start the Thingsboard-Gateway using this command. Let's wait for a while for the service to restart. And let's turn to the dashboard again. Now you can see the new readings every 5 seconds. You can modify the configuration file to get a different sampling rate. For more detail of Thingsboard-Gateway configuration, you can browse its official website. There is a second sensor I bought from an online store. I would like to show that the configurations vary from sensors to sensors. First, let's see the picture. The yellow wire is notated as 485A and the white as 485B. These 2 pins are identical to the pins D+ and D- of the first sensor. On the right side, it is the datasheet I captured online, and I put my translation for better readability. First, we find that the temperature is in input registers instead of holding registers, as the first sensor is. And the register address of temperature is 1, and that of humidity is 2. From somewhere on the web, its default baud rate is 9600, and the data format is N81. These 2 values are identical to the first sensor, and actually they are commonly used among sensors. The default address is 1, but I changed it from 1 to 2 for this demonstration, so that I can connect them together in one Modbus RTU network. Now let's get some readings from the second sensor. Again, we stop the Thingsboard-Gateway to check the second sensor manually. According to the default values, this is the command to get the reading. Oops! This time we failed to get the result. And let's play the increase by 1 trick. Change the register address from 1 to 2. Great! So the temperature is 32.9. Let's do something to the first sensor. So from the first sensor, the temperature is 25.4. The readings of temperatures from the first sensor is lower than that of the second sensor. The different readings are possible because they are not calibrated. I'll change the configuration file and make the Thingsboard-Gateway to read the second sensor instead of the first one. So we open the editor. The first item to change is unit ID because I have changed the slave ID of the second sensor from 1 to 2. The next item is function code. The temperature is in input registers rather than in holding registers. We got to have 4 for this item. And the last one is address. Let's do the same to humidity. Leave the editor and save the configuration file by Ctrl X. Restart the service to make it effective. Now let's check the dashboard. Okay. The temperature went high to above 30, so we know the reading is now from the second sensor. And actually the configuration file originally installed by the initial setup is compatible with all the default value of the second sensor. If you got something alike, it would be completely plug and play. You don't need to modify anything. In this video, some brief introduction of Modbus was described. Also, I have demonstrated how to configure 2 different Modbus sensors on IGT-22-DEV and make the result visible on the demo dashboard. Hope you can work well with your own sensors. I'm Raymond. Thank you for watching. See you next time.